Under the CSIR BMBF project activity, jointly in between Central Electronics Engineering Research Institute Pilani and Ferdinand Braun Institute für Hochfrequenztechnik Berlin, a gallium nitride HEMT based polar liquid sensor module is designed, fabricated, packaged, and characterized for detecting liquids of different polarity and small nano level traces of heavy metal ion, mercury in water. This is the gallium nitride HEMT based sensor chip jointly developed by FBH Germany and CSIR CD India. A 1.21 cm² chip is processed using stepper and EBL. This chip is diced into multiple sensors, each having an area of 6 mm². This single sensor is packaged using thick film alumina based packaging. Now the packaged sensor is connected to a SMU measurement unit for the sensing of polar liquids at 3.3 volt. Sensor is sequentially immersed into the different polar liquids such as acetone, methanol and water, and the relative drain current response is measured with respect to the dry condition. Lowest current is recorded in the acetone and the highest is recorded in the methanol. This graph correlates the dipole moments with drain current. Since the dipole moment of acetone is highest among the other two, hence the drain current is the lowest. Because the larger the dipole moment is, the larger will be the difference in electronegativity of the bonded atoms. In other words, the electron will spend more time around the atom that has the larger electronegativity. This will result in reduced 2-deg and hence in the reduced current. Therefore, by looking at the drain current graph of the unknown liquids, one can differentiate between the liquids of high dipole moments from the liquids of low dipole moments. Next, the sensor is checked for the detection of nanomolar mercury in water. For this, the sensor is submerged into water and then moved to another contaminated water sample having nanomolar mercury ions. At each transition period, the drain current response is measured at 3.3 volt with respect to the dry condition. A significant change in the drain current confirms that the sensor is nicely able to detect nanomolar mercury in water. We also developed the handheld electronic system for detecting the above shown polar liquids using packaged HEMT. System consists of 3.7 volt lithium polymer battery, AS1329 IC used for stepping up the voltage, instrumentation amplifier INA114 AP for gain, Arduino MKR1000 microcontroller and a Nokia 5110 LCD for display purpose. Firstly, the system is tested for polar liquids such as acetone, methanol and water. Under the dry condition, system showed a base current of 16.42 mA. The sensor is now dipped into acetone and the drain current is changed by 0.16 mA. Sensor is now moved to methanol having low dipole moment, and according to that, the delta change is increased to 0.24 mA. Sensor is then moved to water, stabilizing at a current of 0.2 mA. The same trend has been already achieved while testing on SMU unit. In another test of heavy metal mercury using a different sensor, system showed a change of 0.53 mA in water. As it is immersed into nanomolar mercury contaminated water, drain current is changed to 0.71 mA. Hence the system is capable of detecting nanomolar mercury in water. Project leaders deeply acknowledge CSIR BMBF for funding, Director of FBH and CD for motivation and support, and all the team members for their sincere efforts to get the positive outcomes.